All right. Good morning, learners. You are welcome to today's lesson. We will be talking about chemical reactions under uh, grade 9. Okay, it's a very interesting topic. You are familiar with it back from grade 7 and grade 8. Okay, so your presenter is Said Razak, and you are welcome. All right, um, this is how my presentation is going to be. We are going to have an overview to the topic of the topic, and at the end of the day, we will do assignment. Right. Then, okay, so we are looking at chemical reactions, and the subtopic is talking about chemical equations. So our learning objectives or our lessons objectives will be that by the end of the lesson, you should be able to explain what a chemical reaction is. You should be able to balance an equation. You should be able to what represent chemical equations using various forms like the models, the symbols, and the words. All right, let's kickstart. All right, let's just recap. In grade 8 under matter and materials, we learn about what chemical reactions I told you for the first time. Can you remember some of the main ideas about chemical reactions? All right. But so, if you don't remember, but you can be thinking about it. You remember that during the chemical reactions, materials are changed into what? New materials with new chemicals and new physical properties. So we say in the materials that we start are called what? Reactants. And the new materials that are formed are called what? Products. And we also learned that during a chemical reaction, atoms are what? Rearranged. Okay. Before they are rearranged, their bonds will have to what? Broken in the reactant, and new bonds are formed what? In the product. So in this chapter, we are going to build on these ideas, and we will focus on how to write what? Chemical equations, and how to balance chemical equations or reactions. All right, now let's get going. All right, so what is a chemical reaction? A chemical reaction is a process whereby one set of chemical substances react with another set to form a new set of chemical substances. Chemical reactions occur when elements and compounds or elements or compounds combine to form new substances. A chemical reaction is accompanied by what? Chemical change. So what we know is that in chemical reaction, we have got rearrangement of atoms to form what? New products. And when these products are formed, the properties of the product are different from the original reactants. So what happens to the number of atoms? No atoms are lost or gained in chemical reactions. They are simply rearranged. This means that the number of atoms of each type on the left should be equal to the number of atoms on those that are on the right. So this you remember in grade 10 you will be talking about conservation of atoms. That falls under conservation of matter. We have conservation of atoms, conservation of matter, and we even have conservation of energy, but that will be in grade what? 10 as you. So this one is just introducing you. Okay, let me repeat that again. When reactants on the left combine to give you products on the right, what happens to the atoms? No atoms are lost or gained in chemical reactions. They are simply what? Rearranged. This means that the number of atoms of each type on the left should be equal to the number of atoms of those that are on the right. All right. So let's move on to the next point. What is the difference between reactants and products? Reactants are substances that react with one another, while products are the new substances that are made during chemical reaction. All right. What is the meaning of the arrow when writing a chemical equation? A chemical equation is a symbolic representation of what? Of a chemical reaction in the form of symbols and formulae, wherein the reactant entities or the reactants are given on the left-hand side and the product entities on the right-hand side. So the arrow separates the reactants from the product. The arrow tells you that the reactants will react together to form what? The product. Now let's look at chemical reaction representation. How do we represent a chemical reaction? We have got different forms. One way of representing is by using word equation. Now, what is a word equation? So word equation is just writing the element. If it is hydrogen, you write hydrogen, but not the symbol. So all those substances that are involved, you write them in words and not in symbols. So when you write them in words, then that is a word equation. So when we represent a chemical reaction in terms of words, we write a word equation. For example, when hydrogen gas reacts with oxygen gas to form water, we can write a word equation for the reaction as follows. So hydrogen plus oxygen will give me what? Water. So the hydrogen and the oxygen are the reactants, and water is the product. All right. To the left of the arrow, we have, that is before the situation. This side represents the substances that we have before the reaction takes place. They are called what? The reactants. So take note. So what are reactants of this reaction? You can guess. We have hydrogen and oxygen. To the right of the arrow, we have the after situation. This side represents the substances we have after the reaction has taken place. They are called the product. What is the product of this reaction? Yes, your guess is as good as mine. From the word equation, we have water. Now, besides representing chemical equations with words, we can also represent them using pictures. And when we use pictures, they are called picture equations. The same reaction of hydrogen reacting with oxygen can also be represented in pictures called submicroscopic diagrams. Take note. The diagram below shows that the atoms in two hydrogen molecules, H2, and one oxygen molecule, O2, on the left rearrange to form the water molecule, H2O, on the right of the arrow. Hydrogen atoms are white cycles and oxygen atoms are red cycles. So let's look at the representation here. Very good. So you can see that we have got the word equation representing in this form, which is what? The pictorial representation. So what kind of representation is this? Is it microscopic, submicroscopic, or symbolic? We have just heard from the previous slide that is what? Submicroscopic. All right, now we are going to convert our submicroscopic picture to symbolic one. What is the product of the above reaction? What are the reactants of the above reaction? Write their formulae. Okay, so we shall see that in the previous, in the next slide. Now, so we have looked at word equation, we have looked at picture, we are now going to look at what? Symbols. We can say symbolic representation. When we represent a chemical reaction in terms of chemical formulae, that is symbols, it is called a chemical equation. So a chemical equation is the representation of a chemical reaction using their formulae. In another way, the chemical equation for the above reaction would be as follows. So let's not talk about the twos now. Before them, hydrogen is H2. Remember, it's a molecule. Oxygen is also a molecule. That's why they are O2. It means two atoms of hydrogen react together to give you a molecule plus oxygen atom, meaning another two atoms of oxygen reacting to give you what? Oxygen molecule. Then they react together to give you what? H2O. That is the symbol. Now, after you have done that, you have to make sure that the equation is balanced. Remember in the previous slide, we said that when substances or atoms react together, when compounds or molecules react together, the atoms before and after are equal. So how do we do that? We have to balance them. And when we are balancing, we write numbers in front of the product and also the reactants. They are called coefficients. So you can see that before hydrogen, we have got 2 there. Oxygen, we have got 2. The product, water as a whole, we have got 2. Now, so let me just give you a preview about balancing of equations. So what we are going to do is that you have to check whether the number of hydrogen atoms are the same on the right. So you see that if I multiply the 2 in front of hydrogen, if I multiply it by 2 down there, it's going to be 4. So it means on my left-hand side, hydrogen is 4. Then let's go to our right-hand side. If I multiply 2 by the 2 attached to the hydrogen, I also get 4. So it means on my left-hand side, I have 4. On my right-hand side, I have 4. Then when I multiply 2 by 1, the oxygen there is like there is 1 under there. So, but it's just the same thing, like not indicating it. So 2 times 1 will give me 2. So you will see that on my right-hand side, my hydrogen are 4, left-hand side they are 4, right-hand side oxygen they are 2, left-hand side oxygen they are 2. So this tells me that my equation is balanced. All right, so let's go on. What kind of representation is this? Is it macroscopic, microscopic, or symbolic? We still have reactants on the left and products on the right. So this picture here you are seeing gives you a vivid or a clear representation of these concepts: macroscopic, submicroscopic, or symbolic. All right, so when I have H2O, it means I'm using their symbols or formulas, and that is the symbolic level. So symbolic level is using words and symbols. Okay, so let's go to what? Submicroscopic level. Now, submicroscopic level is when I am using my imagination to try to represent water. So using your imagination to think in terms of particles, that is submicroscopic level. Then there in the beaker, I have water there that I can see. That is macroscopic level. And the macroscopic level is what you observe. That is, you see, you hear, you smell, you taste, and you feel. That in effect, these are the what? The 5 senses. Okay. All right, let's move to the next. If you have any question, you take note of it. We'll meet around the chat box so that we can, in the chat room, so that I will answer your questions. So let's move to the next. Now let's go to what? Chemical equations. Chemical equations represent what? Reactions. Chemical reactions can be represented with models. And chemical reactions are usually represented with symbols such as in the equation, such as in chemical equations. So for example, I have C plus O2 giving me CO2. That is carbon reacting with oxygen giving me what? Carbon dioxide. So what kind of representation is this? it's going to be what? Symbols, because we are using the symbols of the element. Now let's go to the next one. We have already seen the second equation, that is hydrogen, 2 atoms of hydrogen, 1 atom of oxygen, and then giving us what? 2 molecules of water. Now let's listen. The subscript number indicates the number of atoms of an element found in the formula. The numbers in front of the compounds indicate the ratio in which the molecules react. Remember, I told you they are called coefficients. So for example, let me just explain this second bullet. It says the numbers in front of the compounds indicate the ratio in which the molecules react. So if I look at the first equation, carbon reacting with oxygen to give me what? Carbon dioxide. Then the ratio is going to be 1:1:1, meaning we have got 1 atom of carbon reacting with what? 1 more oxygen molecule, then also reacting with what? 1 carbon dioxide. Now let's come to what the second equation. So when we were balancing it, we wrote this one in the previous. So the ratio in the second equation is 2:1:2, because we have got 2 hydrogen molecule, then reacting with 1 oxygen molecule to give us what? 2 water molecules. That is 2:1:2. So that is the ratio. Okay. Now let's go on. So for example, 2 molecules of hydrogen react with 1 molecule of oxygen to form water. Therefore, the mole ratio is going to be what? 2:1. So when you look at the formula, hydrogen is 2, oxygen is 1. So meaning for oxygen as a compound or as a molecule, the moles are 2 for hydrogen, 1 for oxygen. Okay. No atoms are lost or gained in the reaction. They are simply rearranged. Okay, we have already seen that is conservation of atoms. All right. Now let's look at balancing equations. Chemical equations must be written as balanced chemical equations. The total number and type of atoms of the reactants is the same as in the product. So in another way, balanced equation simply means that the number of atoms of the reactants should be equal to the number of atoms of the what? Product. Okay, so let's look at these equations below and see whether they are what? Balanced. So how do we balance? As I have already indicated in the previous lesson, in the previous slide, I mean, for you to check that an equation is balanced, you have to check the same species or the same atoms on the left-hand side is the same on the right-hand side. So for example, if I'm going to check this equation, remember, is known as what? Raster. When iron is exposed to the environment, it will react with the moisture and oxygen, and then it will what? Undergo oxidation. So on my left-hand side, iron is 4. So when I come on the right-hand side, you see there is 2 times 2, that is 4. Okay, then that is fine. Let me look at my oxygen again. 3 times 2 is 6, and 2 times 3 is also 6. So that is how we check. So it means this equation is balanced. Now let's look at the next equation. We have got magnesium reacting with oxygen to give us what? Magnesium oxide, which is also known as white powder. Now let's check whether it's balanced. So the magnesium atom on the left is 2, on the right is 2. So 2 times 1, the subscript is 1. So when I multiply by that, I get 2. So it means on the left and on the right, I have 2. Then oxygen is 2 atoms. Now 2 times 1 is also 2, meaning it's balanced. Now another example is copper reacting with oxygen to form copper oxide. This is a very slow type of reaction. So Here we have is represented the word equation and the word chemical equation. Because remember, sometimes they can say, write, they can give you a scenario in the sentence form and say, write a word equation and in the word chemical, symbolic or chemical equation. So in word, we have got copper plus oxygen giving us what? Copper oxide. That is the chemical equation. Now, that is the word equation. Now, the chemical equation or symbol equation will be copper plus oxygen giving us what? Copper oxide. Now, the two in between. Yeah, so two in between and before the elements are what? The balanced. So when I check on my left, copper is 2, then on my right, copper is also 2. Then on my left, oxygen is 2. On my right, oxygen is also what? 2. Okay, so there is an error that is omitted there. So we're talking about balance equations. So when something is balanced, it means it should not be tilting. Everything should be equal. Your left and your right should be equal. Okay, now it's time for assessment. Okay, so now what we are going to do is that this is the question, and you will submit your answers through the chat room. So I will want you to indicate your answer. Number 1, you have your answer. Number 2, your answer. Number 3, your answer in that form. Okay. All right, so let's go on. Which of the following is not an illustration of water? Look at the question very well. Which of the following is not an illustration of water? Okay, so this one, you just write your answer. But take note, it's a very tricky one, but it's very simple. Which of the following is not an illustration of water? Okay, let's go to the next. Let's go to the next question. All right. Write the following chemical equations as word equation. As word equation. Okay. Yes. So each equation is 3 marks. So your reactants are 2, so you have 2 marks. Your product is 1 mark. The same thing, so you get 3 marks. Now write the following word equation as chemical equations. Yes, so we have them there. Right. So I give you time to do it, then we will discuss in the chat room. Okay. All right. So if you have any question, you might submit. All right, you guys are doing very well, except some of you. Question 1, you are not getting it right. Read it again. All right. Tando, that's very good. Carbon plus oxygen giving us, that's correct. Kai, double check yourself. Kai, your answer, check it again. And Onkabetwe, please also check your answer, your equation. We don't put one after oxygen. All right. Tando, where is your answer for question 3 B? Okay, cool. That's nice. Lucipo, also check your equation. Check your answer. Uliswa, also check your answer again. All right. I hope we are getting there. Yes, that's perfect. Okay, guys, question 1 is very simple, but if most of us are not getting it. It says, which of the following cannot represent water? You see, so double check, guys. Double check your your answer for question 1. But I'm impressed. Question 2, most of you are getting it except 1 or 2. All right. Okay. Okay. Yes, Tando, you are almost there, except hydrogen should be, you should write it in a molecular form. In that case, all of this is going to be right, except your last one of your products, which is hydrogen, should be H2 and not H. Yeah, and that one you are perfect. Okay. All right. So guys, let's quickly check our answers. All right. Okay. So let's go on. All right. Number one, they are all correct ways of representing water. So I told you, you remember we said we can represent a compound either in symbols or in word or in picture or even in formula. The formula, remember the formula is the same thing as what? Symbols. So all those things I told you is very simple, but it's tricky. So the question one, they are all correct ways of what? Representing water. Okay, question two, write the following chemical equations as a word equation. All right, so those of you who got it, you are right. So carbon plus oxygen giving us what? Carbon dioxide. Now let's go to magnesium. Some of you also got it right. They said we should write the word equation. Magnesium plus oxygen giving us what? Magnesium dioxide. Now, similarly, question 3 says, right, they gave us a word equation and they want us to write what? The chemical equation. Or in other way, they want us to write it what? Using the formula. So sulfur is S, oxygen is O2, and then sulfur dioxide is SO2. So most of you got it right. B says carbon monoxide plus water, giving us what? Carbon dioxide plus what? Hydrogen plus what? That's all. So when we come to the where symbol is CO, so CO is carbon monoxide plus water, giving us carbon dioxide, and then what? Hydrogen gas. Okay, so for now, we are not even bothered whether it's balanced or not. Our main aim is just to learn how to write them, then after we can check them. So what you have got now on your own private time or tomorrow, we shall check to find out whether we can balance them. Okay, now let's look at the lesson summary. So we have been talking about what? Different ways to represent chemical equations. So one, we say we can represent chemical equations using models and pictures. And when we are doing that, we are talking about what? Submicroscopic representation. So when you are trying to think about how you will represent something, then you are talking about what? Submicroscopic representation. We also said we can use symbols and formulas in chemical equations. And then we also said that we can also use words to what? Represent a chemical equations or reactions. Okay, we must take note. Then we also said that numbers are used in two different ways in chemical equations. We have coefficients in front of chemical formula indicate the numbers of atoms or molecules of a specific type that take place in the reaction. And we said subscript inside chemical formula indicate the number of atoms of a specific type in that particular compound. Chemical reactions happen when atoms in chemical rearrange. No atoms are lost or gained during a chemical reaction. In a balanced equation, equal numbers of the same kinds of atoms are opposite sizes of the what? Reaction. Okay, now there is a mind map here that illustrates what we have just learned. Okay, so we have got chemical reactions. So chemical reactions involves rearranging and no loss of or gain of atoms. Now, chemical reaction can be represented by models using symbols. We can also use symbols in chemical equations, and the equation must be balanced. And when we're talking about symbols, we can use letters. We can also use what? Numbers. And when we are using letters, we represent the type of atom. And then when we are using numbers, we can represent them in terms of subscript and coefficient. The subscript represent the ratio of atoms in the formula, and coefficient represent the ratio of molecules that react. Now, when we're looking at balancing, we are saying that total number of atoms and total number and types of atoms in reactants should be the same as those what in the product. So that is from the start to the end in the reaction. All right. That is the end of the lesson. So if you have any question, you can ask now, or you wait tomorrow. Then we you can ask, and then I will attend to it. Our lesson has come to an end, and hope to see you tomorrow. And I'm very sure you have enjoyed it. You can feel free to express your feelings about the lesson when you are not enjoying it. If I am fast, you let me know. If I'm slow too, you let me know. And thank you for attending. See you tomorrow and enjoy the rest of your what lessons.